Good morning. Human eye, defects and remedies. Defects and remedies can be discussed in case of human eye. Already we have seen a video regarding the structure of the human eye, and the basic important points in that are: human eye essentially consists of a convex lens which is backed by a screen. The name of the screen is retina. It's an optical nerve. Whenever light is incident on that optical nerve, the nerve vibrates and the pulse of vibration is sent to the brain, and the brain able to sense the image. So therefore, retina is a very important organ, that is important nerve, optical nerve that is. The human eye essentially consists of a convex lens. It is a convex lens which is thicker at the middle and thinner at the edges, of variable focal length. The convex lens can change its focal length. Focal length can be decreased or focal length can be increased. As focal length decreases, power can be increased, because reciprocal of focal length is called power. That lens is backed by a screen called retina. So this is, the lens is made by the God. It is not made by the human being. So that's why it has a flexibility. Ciliary muscle is the reason for it. It can change the shape and size and hence focal length of the convex lens. Ciliary muscle able to change the shape of the convex lens and focal length of the convex lens. With the help of this ciliary muscle, that is possible. So the power of the eye lens is adjustable. The power of the eye lens is adjustable at our desire by this muscle. This is called accommodation power. We call it as accommodation power. Eye has an ability to accommodate the image on the retina always, as long as the human eye is a healthy eye. Of course, with the age, the power of the ciliary muscle gradually that fades off. That means decreases. That is, with the age, as the age increases, its power also that changes. This is called accommodation of power. Accommodation power. The power of the eye lens is adjusted that it forms an image of observed object at screen. Suppose when you are observing an object in front of us, we are trying to read a newspaper, the image of the news can be brought to the focus of what? Retina. So the image will be formed on the retina, and that can be seen again with sufficient magnification without straining eye on the paper clearly. So the power of the eye lens is adjusted that it forms the image of the observed object at screen and it becomes visible. If there is some dislocation, the dislocation is there. Near objects are seen because image is forming on the retina, and far objects also seen because the image is formed on the retina. In both the cases, lens able to adjust its focal length by becoming thinner and thicker by changing focal length accordingly to form the image on the screen. So if there is some dislocation, in case if you unable to see the image clearly, that means, so that is, image is not forming on the retina. It is not forming on the retina. If there is some dislocation, inability to adjust power of the lens, the object becomes invisible. It's not clear. A blurred image can be seen. The image is not clear. So under this circumstance, the image is either, that is because the image may be either formed in front of the screen or behind the screen. So due to high power As power increases, the focal length decreases. As focal length decreases, the eye lens is able to converge the light at a point which is before the retina, so that the image cannot be seen clearly. Because the image is not forming on the retina, eye is not able to accommodate the image on the retina. So therefore, definitely the eye is suffering from some defect. Sometimes the image can be formed behind the retina. So in this case also, eye is not able to accommodate the image on the retina. As focal length increases, the image is forming behind the retina. That means power is decreasing. The power of the human eye is decreased, the focal length increases. So therefore, the human eye able to form the image behind the screen, behind the retina. So please carefully follow this sentence. If there is some dislocation in ability to adjust the power of the lens, the object becomes what? Invisible. The image is either formed before the screen or behind the screen. That means retina. Due to high power and lower focal length, image can be formed ahead or before the retina. Image is forming before the retina. See now, image is formed here. It is forming here. Image is forming here. So this is retina. This is retina. It's not forming on the retina. It is before. That focal length is now decreased. As focal length decreases, the power of this lens is increasing. So you need to adjust the power of the lens. That means you have to remove some factor of what power. That means you have to reduce the power of the lens. To reduce the power of the lens, you have to go for what? A concave lens. A concave lens or a divergent lens, because a divergent lens will have a negative power. A negative power. Your power is increased, therefore you have to reduce the power. To reduce the power, you have to incorporate a lens whose name is concave lens, because it has a negative power from this positive power. So certain value of power must be decreased by adding, by associating, by a concave lens, a divergent lens. So if the image is formed before the retina, we must go for a concave lens. When we go for a concave lens, the power will be reduced, so that focal length will be increased. As focal length is increased in such a way that again the image is going to be formed on what? Retina. Again the image is going to be formed on the retina. See children, please try to follow again. See here, sometimes I cannot accommodate the image on the retina. So that means image is forming before the retina or image is forming after the retina. See here, this is after it is formed. In this case, image is formed before. When the image is formed before the retina, the focal length of this human eye is decreased and the power is increased. The lens, the human eye is now suffering with what? Increase of power, decrease in focal length. Decrease of focal length. So that we have to incorporate a lens that is called concave lens. When the concave lens is associated with the eye, that means if we use a concave lens with what? The eye. So the power of the lens will be decreased, so that the focal length will be increased. As focal length increases in such a way that the focal length will be equals to the distance of the retina from the human eye, so that image can be seen on the retina. So a clear image can be seen on the retina, so that that defect can be eliminated. So that could be the remedy of the defect. This could be a defect and that could be the remedy of the defect. So here, this is an important point. Due to high power or low focal length, image can be formed ahead, that means before the retina. Okay, for vision of far objects, we need a less power lens. So far objects can be seen. We can see the near objects. We cannot see the far objects. So when we are unable to see the far objects, so what we are going to see? We have to choose a lens that is what is called a divergent lens has to be taken. A divergent lens when it is taken, so say now the object, the rays are coming from the infinite distance, say for example, the rays are coming from infinite distance, and when they are coming from the infinite distance, they are diverging like this. When they diverge, so the image can be formed here somewhere in the focus, near the focus, so that again they are incident on the human eye, and human eye able to converge the light on the retina, so that the distant objects can be seen at near points. So this eye is now suffering from what kind of sight? Short sight. And it has short sight. So the eye can see the near objects, but it cannot see the far objects. So that our rays which are coming from the far object are parallel, and when they are incident on this divergent lens, they are diverging. As they diverge and incident on this convex lens, the convex lens is able to converge the light on the retina. In such a way, the lens is going to be prescribed. So the focal length of this lens is prescribed in such a way so that after these rays are diverging from this divergent lens, again they are incident on the convex lens, and they are able to focus on the retina. The defect is going to be eliminated. So people one who are suffering from myopia, that is myopia, short sight. This is called short sight. And they have short sight, they do not have long sight. So for such people, we must recommend a concave lens. This must be a concave lens or a divergent lens. So children, please understand, the image is forming before the retina. That is due to less focal length and more power. Because the power of the eye is increased, we have to reduce the power of the eye with an aided eye. Aided eye means we have to incorporate a concave lens whose power is usually negative. So if you add a negative lens to this eye, the power will be reduced and hence focal length will be increased. So again the image is going to be formed on the retina. On the same way, due to low power and higher focal length, the image can be formed behind the screen. So image is formed behind the screen. This is behind the screen. This is what in front of the screen. Earlier in front, and this is what behind the screen. So when it is formed behind the screen, this could be the focal length. Then the focal length is increased. Reciprocal of focal length is called power. Power of this human eye is decreased. So I have to increase the power of the human eye. To increase the power of the human eye, you have to take a convex lens. When you take a convex lens, definitely the power of the lens will be increased in such a way that the lens is again going to form the image on the retina. So with sufficient magnification, without straining the eye, we are able to see the image on the retina. This is called hypermetropia. We can see the near objects in the earlier case. Now we can see the far objects. We cannot see the near objects. When we are unable to see the near object, we are unable to read a newspaper. So under these circumstances, we have to take a convex lens. This is an aided eye now, aided eye. If you take a convex lens, the effective power of the human eye will be what? That is increased. So when it increases, the focal length will be decreased. So again, these rays will be converged on the retina. Again, these rays are converging on the retina. Children, please remember, this is called short sight. This is called long sight. Short sight is due to the image is forming behind that is in front of the retina. Because it is forming in front of the retina, so the focal length of this human eye decreases. The focal length has decreases, power must be what? That is, power is increased. Because the power of the human eye is increased, we have to reduce the power of the human eye by taking or considering or by associating a lens called concave lens whose power is negative. So suppose it has some 10 diopters and this has 2 diopters. That is minus 2 diopters, 10 minus 2. So that becomes equals to what? 8 diopters it becomes. So that again the image is going to be formed on the retina. So right. In the second case, the image eye cannot accommodate the image on the retina. So it is accommodating the image behind the retina. That means focal length of the human eye is increased and the power is decreased. Because to increase the power, we have to use a lens which has a positive power. Positive power means a convex lens or a convergent lens will have a positive power. A convex lens is now considered and it is kept in front of the human eye so that the effective power will be what is happening, that is increased and the focal length will be decreased. As focal length decreases, again the human eye able to form the image on the retina. So this way we can eliminate the short sight by using a concave lens, and long sight we can eliminate by using a convex lens. This can be understood easily once you go through it once. Thank you.